right? So let's say yeah, this chapter will take only one class. So this is how much this short this chapter is, and yeah, we will understand one by one every important terminology, right? So, what are the important terminologies do we have? So, we will have deformation, right? So, we will have deformation, and on the basis of deformation, we will define the materials, right? So, as you guys saw that in the system of particles, what kind of objects or materials did we understood? Did we understand? What kind of system of particles we studied? Yes, guys. What was the system of particles that we studied? We studied about the rigid bodies, right? So they don't change their shape and size. Those kind of objects, materials we studied in that system of particles, right, everyone?
Yes, sir.
Yes, sir.
Yeah, but now in this chapter, we will see that if we have a force of deformation which is very large enough, then we can even elongate a steel rod, right? We can apply some very high value of force, and then we can stretch this steel rod, right? So that we can do. So then these things would not be longer the rigid bodies, right? Because they are changing shape. So in reality, the objects are they're not the rigid bodies, right? So if we apply some large enough force, and those forces are in a very greater amount, right? So if we apply some large enough force, then the shape and size of the object or the material can change, right? And if the shape and size of the materials are changing, then we can have kinds of objects, right? So then we'll talk about, yeah, so first we'll talk about deformation, then we will talk about what kind of force we are applying and how much deformation is taking place, right? And then we will talk about the relation between stress and strain. So this is all we will understand in this chapter. So these are the only relation between stress and strain. So these are the things that we will study, right? So let's say that we have a deforming force, right? Force of deformation in this direction. So this will stretch, right? This will elongate. And if this object can revert back to its initial state, right? So that object has a different name, and if it cannot be reinstated at its initial state, then that object is has a different, right? So on the basis of deformation, on the basis of deformation, we have two kinds of objects. One is elastic, and the other one is plastic, right? So what is the elastic material? So elastic material is defined as the tendency of the material, or the property of the material, tendency of the material or the property of the material by virtue of which material can regain its initial state. So this property is called, the property is called elasticity. So elasticity is the property, and the material would be called elastic material. Elastic material, right? And then then we have this plastic material, right? So the tendency of the material by virtue of which it cannot revert back to its initial state. That property is called plasticity. Plasticity, and the material is called the plastic material, right? So physics definition is different. So let's say you have some putty or mud, right? So if you change the shape of the mud, so you have seen those. So you have seen those mud artists, right? So they make some shapes, right? So those muds can be deformed in a different shape, and they cannot revert back to its initial state, right? But let's say we have this what is this thing? So let's say I have this pen. Yeah, okay, this will have, yeah. Let's say this this thing that I have. So if I change its position, then it can regain its initial state, right? So this is some kind of an elastic material. But in the case of the mud, right, or some putty, so those kind of things, when we apply the deforming force, they cannot revert back to its initial state, right? So those kind of things are called plastic material. And then there are different kinds of deforming force, right? So depending upon that, there are different divisions. So on the basis of the deforming force, right? On the basis of deforming, there are different kinds of stress. So what is stress? First, let us talk about the stress, right? So let's say we are applying a deforming force on this cylinder. So we can apply the deforming force in two ways, right? So one would be that we apply the deforming force in this direction. So this is deforming force, and from the Hooke's law or from the restoring force, right? So the restoring force would be applied in this direction to revert back to its initial state. There would be some restoring force which will act in this direction. So this is F restoring, and that is acting normally to this surface. So this has some area of cross section. This is area. So the stress is defined as, so stress is defined as the ratio of the restoring force and the area of cross section is called the stress, right? So this is the stress. How do we define stress? So stress is force, restoring force divided by the area. So this is the stress. And there are mainly three kinds of stress, right? So mainly there are two kinds of stress, and yeah, so there are two kinds of stress. One is the longitudinal stress, and the other one is this tangential stress, right? So if I apply, you see that I'm applying this force perpendicularly, right? So if I apply this force perpendicularly, so that would be called the longitudinal stress, right? If I am applying the force perpendicularly to this area of cross section, so that is called the longitudinal stress. And if I apply the force like this way, right? So if I apply the force like this way, deforming force, so that this is the area of cross section, right? This is the area of cross section, and I am tangentially applying the force to this area of cross section. So this is tangential, and this is longitude. Okay, and one more kind of longitudinal stress is there, and that is this one. So let's say I have this material, right? Bulk material, and I'm applying the force in this way. So these are all normal forces, right? So this is acting perpendicularly to this surface, right? So this is again longitude. So there are two kinds of stress, longitudinal and tangential, right? So due to this part, and longitudinal is again defined in two ways. One is the tensile or compressive stress, and the other one is this bulk stress or hydraulic stress, right? So tensile and compressive are different stress. I will talk about them. So, but this one is the bulk stress, right? So this is bulk, and this one. So what I'm doing for this case, if I'm applying this force in this direction, so this will elongate or this will compress. What will happen to this thing? If I apply the force in this direction, so it will elongate or it will compress. Yes. Yes, if I apply the longitudinal force in this direction, so it will elongate, right? In
Yes,
this,
sir.
yeah. So if the force is elongating the material, so that would be called the tensile stress, right? If I am
Yes, sir.
applying the stress, longitudinal stress, and that is elongating the material, so that is tensile. And if I am applying the stress and that is compressing that thing, so that would be called the compressive stress, right? So these are the kinds of stress that we have. And then we have this tangential stress. So this is also called shear stress. So we have three kinds of stress. One is this tensile or compressive. Then we have hydraulic, and then we have these shear stress. So all these different stresses have different purposes, right? So we'll talk about them individually. So first, let us write about tensile stress. So if the longitudinal force is acting in such a way that the material has been elongated. Elongated, then it is called tensile stress. Right. So let's say I have this wire and I apply some deforming force in this direction, then it will be elongated, right? So this elongation is, let's say, this length is L and this elongation is delta L. So this would be called the tensile stress, right? So tensile stress is F by A. All these stresses are similar, F by A, right? And then so and then we have this compressive stress. So if the
The
longitudinal
tensile stress and compressive stress are the same thing.
no, no, no. So they are not the same thing, but they are. the force is the same, right? The force is acting perpendicular. So in one case, the material has been elongated, stretched out. So in this case, in tensile stress, the material has been stretched out, right? And in this case, the in compressive stress, the material would be compressed, right? So I will just show you guys.
Okay, sir.
In the if the longitudinal force is applied in such a way that the yeah, that the material has been compressed, then it is called the compressive stress, right? So let's say if you have this thing, right, and you are applying a force in this direction, deforming force in this direction. So this will shrink, right? And now this will be like, so you will have a shrink of length, which would be, let's say, delta L. So earlier it was, yeah, let me write it in here. So this is L, and now it has been shrinked by this length, delta L. So again, the forces are perpendicular, right, to this area of cross section, but they are in different direction. Earlier, the force was in this direction, perpendicular to this one, but in this way, the force is in different direction, but again perpendicular to this area of cross section, right? This one is compressing, this one is elongating. So this is the only difference between compressive stress and tensile stress, right? And if you have, yeah, so if you have, then the other one was this hydraulic stress, right? So if in a material the forces are acting perpendicularly from all directions, then it is called the and then it is called the hydraulic, or we can also say that volumetric stress, right? So if we have this kind of an object and we are applying from all the directions, right? So you can see that this will shrink. This will shrink. So this will have some shrink of volume. So these kind of stress are called the hydraulic stress. So these are the, and then the last one is this shear stress. So when the deforming force is applied tangentially, then it is called shear stress. So I have this thing, right? And I apply the force in this direction, which is parallel or tangential to this area of cross section, right? So this kind of stress is called the shearing stress, and all these stress have same numerical formula. So force divided by all these have same force by E. Okay, so these are the kinds of stress that we have, and you see that all these stress are deforming the object, right? All these things are deforming the object that you can see, right, guys? Is
Yes,
this
sir.
Yes, sir.
so when the objects are deforming, so let's say if I am applying the stress in this direction, so this will be like this, right? So in this direction, I have deformation. Let's say this is delta x, right? So I have deformation in this direction. This will have a deformation in, so this was this size and it has become a small size. So we have a deformation in this way, and in this way we have a deformation delta L and delta L. So these kind of deformation we have. So there's one another physical quantity which is defined from this deformation, and that is called the strain, right? So strain it is defined as the ratio of change in configuration over the actual configuration, right? So I will individually write what are the longitudinal strain, right? So first one is the longitudinal strain, and to be precise that compressive or tensile strain. So that would be, I denote that as longitudinal. So deformation is delta L divided by L. Okay. Similarly, I have a shearing strain, and that is defined as what would be shearing strain? Can you guys tell me? This one was L, right? This is the change in configuration. So what would be the shearing strength? Yes, this is the change in configuration, delta x. This was the original there.
So will it be L by delta x?
So always the change in configuration divided by the actual one. So delta x by L. Yeah,
Okay, sir.
you are nearly correct. So delta x by L. Okay. And the third one is this bulk strain, right? Which is called the volumetric strain. So volumetric strain changes the volume, right? So we saw that the volume was changed. In this case, the volume was changed, right? So this is defined as delta V by. This is what we call all these strains. So in the next part, we will understand about the properties of the elastic material, right? So if we have an elastic material, then these stress and strain would be related, right? If we have an elastic material, then this stress and strain would be related. So all these things we would understand, right? Okay. So you guys please note it down, and then we will do all these. So we'll understand about things. So deformation we have done, stress strain we have done, and then we will talk about relation between stress and strain. Guys, please note down these portions. And whenever you guys want me to scroll down the screen, please tell. So remember, whenever the material can get back to its initial state, that is elastic. When it cannot, so that is plastic, right? Not the plastic one you understood about, you understand about the chemistry. Not that plastic. Elastic, plastic have different meaning in physics, right? So plastic is what? In chemistry, plastic is what? You guys have chemistry, right? Plastic is what? Yes, guys. We have done these man-made materials, right? You guys have,
Mm,
yeah,
not yet.
not yet man-made, but so after carbon in organic chemistry, so did they
No,
start
in CBSE class or in school?
in CBSE class? Yeah, did they start this
We
organic
are
chemistry?
doing organic chemistry now.
Yeah, organic chemistry. So have you reached this man-made material? Monomers.
No, no, sir.
Okay, yeah. So in chemistry, you will again come across this plastic thing, right? So you seen this polythene, plastic, and all the other things. So these are chemically polymers, right? So the chemical meaning of these plastic are polymers in chemistry definition, and that plastic is totally different from this plastic. This plastic is defined as on the basis of deformation. So if you are deforming that thing and then it is getting back to its initial state, so that is elastic, and when it is not, so that is plastic. So that is the definition in physics. Okay, whenever you guys have noted it down, please tell me, and then we will.
So can you scroll?
One. Yes, whenever you guys want me to scroll down, please.
Done, sir.
Done. Please. Then please.
So the other part I've written.
Oh, these things you have already. So what about?
Yes, sir. When you were writing it.
Yeah. So I guess let us ask one else that whether they have. Yes. Okay. So Rishita and Amna, you guys also tell me that you guys.
Done, sir.
Then these are portion also. Yes.
Yes, sir.
Okay. Then yeah. So if all these things you guys have noted down. Now let us talk about the relation between so for an elastic material, right? For an elastic material, the Hooke's law, right? So physicist Hooke's law. So has stated that all these stress and strain are related, right? So for an elastic material, by Hooke's law, right? Hooke's, it states that stress and strain are directly, or if you like to say that stress is directly proportional to strain for an elastic material. Okay, one. Okay, so what I was, yeah, for elastic material. So Hooke's law states that stress is directly proportional to strain, right? And if we remove this proportionality, so that would be some constant, right? And depending upon the kinds of stress, you have different proportionality constant, right? So if you remove this proportionality, so some constant would be there, and this constant is called modulus of elasticity, right? So this is called modulus of elasticity. And depending upon the different kinds of stress, we can have different kinds of moduluses, right? So we have understood about all the different kinds of moduluses. So let's say for longitudinal, tensile, and compressive stress, right? So for longitudinal, right? So we know that stress is directly proportional to strain, and these are longitudinal, right? Let me write it as longitudinal stress directly proportional to longitudinal strain, right? So longitudinal stress was how much? This was F by A. And if I remove this proportionality and I put a modulus, so this is represented by Y. And longitudinal stress was how much, guys? Longitudinal stress was strain was how much? That was delta L by L, right? So this Y would be how much? That would be stress by strain, and this is F by A divided by delta L by A. So this goes and this comes here. So this is Y, which is F into L divided by delta L. And this Y is called Young's modulus, right? So if we are applying a longitudinal force, right? So there is a restoring force which is acting, and that is also perpendicular. And those restoring force, due to that, there would be stress and strain. So there would be a Young's modulus, right? This constant, proportionality constant, and this is for the longitudinal stress, right? And for shearing stress, right? So for shearing stress, right? Again, the same thing. So what I will do is that I will directly write. So shearing stress is directly proportional to shearing strain. So if we remove the proportionality, so we will get a constant, and that is represented by sigma, right? And this is how much? So sigma is shearing stress divided by shearing strain, and this is how much? So this is F by A divided by delta X by delta L. So this would be again FL divided by delta X into A. So this is sigma. And this sigma is called modulus. All these are modulus, right? So modulus of rigidity or shearing modulus, right? And the last one is the bulk modulus, right? So this is how much? So bulk stress is directly proportional to bulk strain, right? And if we remove the proportionality, so there would be a constant, and how do we denote that constant? So this is represented by B, right? And this B is equal to bulk stress divided by bulk strain, right? So bulk stress is how much? Bulk stress is F by A again divided by delta B by B. So B is how much? FB divided by delta V into A. So this B is called the bulk modulus. Right. So what are these moduluses? Moduluses are the proportionality constant. Whenever we have an elastic material, then these materials will follow these materials will have a proportionality constant, right? So if I plot the stress versus strain curve, so for elastic material, stress versus strain curve is a straight line, right? This is my stress versus strain curve. This is stress, and this is strain. This is an elastic material, right? And if I calculate the slope of this thing, so slope of this thing will give you the modulus, stress by strain. So that will give you the modulus, and we have different kinds of modulus. So is this thing clear to you guys? Is this thing clear? Yes. Are these things clear, everyone?
Yes, sir.
Okay, so guys, don't say that you have already noted it down. Again, did you guys already noted it? So, yes. Okay, if you guys have not noted it down, so please note it down. Right, so this K is stress by strain. right? And from graph, how can we calculate? So from graph, this is a simply slope will give you stress versus that stress. Please note down all these things, and whenever you guys want me to scroll down, please yeah, whenever you guys want me to scroll down, please
Done, sir.
uh, okay, then please note down these questions, and we'll do some question based on this. Yeah. All these things are defined only for the elastic materials, right?
Done, sir.
Yeah. Okay, then please put down this part.
Sir, can I drink water then come?
Yeah, yeah. So, okay, why can't you drink water?
Sir, I'll have to get up and
Yeah,
get
yeah, yeah,
it.
yeah, yeah, yeah. So go and get that.
Okay, sir.
Yeah, so whenever you guys have written it down.
Done, sir.
Done, everyone. Okay, so let us do one question and give a couple of questions. Yeah, should I topics or should I do question? So I will do some topics related to this one, and the question we will do after this one. Let us understand, right? So what did we understand? That from Hooke's law, there is an elastic material, right? From Hooke's law, some elastic material, right? Elastic materials were following this. So stress and strain is directly proportional, right? This is directly proportional, right, guys?
Yes, sir.
Sir.
But we can have some elastic materials also, which doesn't follow this straight line. So they may follow this thing. So this is not a straight line. So in this case, we are seeing that strain, these are not directly proportional, right? So there are some elastic materials which doesn't follow Hooke's law, and those kinds of materials are called elastomers. Okay. So for example, we have these bloods which are following and they flowing in the aorta, right? So we have these arteries and we have these veins. So these arteries are very thick. They have these thick walls, right? And they circulate the bloods in the body. So they are also the elastic material, right? If some more blood is flowing, then they will elongate, and then if the pressure is released, then they will compress, right? So they can come to its initial state. So they are also elastic material, elastic things, but they don't follow this Hooke's law, right? So the aortas, arteries are the elastomers, right? So they don't follow this proportionality. They don't follow the Hooke's law. So we have these elastomers, right? So the kinds of elastic materials which doesn't obey Hooke's law, right? Which means that which implies that restoring stress. Is not directly proportional stress string, right? For example, the aorta's vessels in human body, right? So there, the aorta have this kind of stress versus strain relation. That graph I have drawn it already, but this is the kind of stress versus strain relation there. So this graph is not straight line, right? So write about these last two. These are the same thing that I wanted to talk about, but note down this point. Please note down this point, and
Yes, sir.
then one important thing which is there, which may be asked in the exam, and that we can take care. Yeah, please note it down, and then we'll talk about that. Yeah, whenever you guys have noted it down, please take. This is aorta. Why have I written this aorta? This is aorta. Yes. Whenever you guys have noted it down, please, so, in tomorrow's class, we'll start this mechanical properties of the fluids, right? So that we can start in tomorrow's class because this chapter is.
Sir, I
Yes.
actually have exam on Monday.
Yeah. So this I have a class with you at 10:30, right? So after this class,
Yes, sir, I have
uh,
mechanical properties of fluids in the exam.
yeah, you have mechanical properties of fluids, right? Yeah, tomorrow I will start that portion with Rishita and yeah. But today I can discuss some topics which are important, right?
So, sir, can you can take a backup or
Yeah, backup. Oh, yeah, that is what I will do in today's after this class is over. So that is what I'm going to take, right? On Monday you have exam. Only this mechanical properties of the fluids. Only that you have.
no, sir? I have half of rotational motion. Then I have gravitation, solids and fluids.
Oh, yeah, then a major portion. So same as Akib. Akib had also these chapters, but he is not here. So he was supposed to be.
Yes,
Yeah.
sir. Last time, last exam, you took a backup for me and you gave me like a recap revision.
Oh, yeah, recap. Oh, so
That was really helpful.
that kind of recap you want. Okay, so firstly, I'll have to complete this chapter, then we can talk about the details, right? What I will, yeah, in half an hour, I will just talk about, yeah, so that I can.
So you can take like today or
Yeah, so tomorrow I will start this fluid part, and today I can take the recap of those what gravitation and those yeah, the rotational motion, and then the last one. That, yeah, rotation, gravitation, and this solid I can just recap, right? So that you can revise all. Oh, everyone noted. Everyone, yes.
yes, sir.
Rishita and Amna,
Yes,
did you?
sir.
Okay, so again, what have we learned in this chapter? First, we talked about deformation. Then we talked about different kinds of stress and strain. And then we were talking about the relation between stress and right. So these are the only things that we have studied so far. So along this line, we have another thing which is very important, and that is stress versus strain curve. So from this curve, we can clearly tell about the properties of any material, right? So this curve is very important. So we have this curve. So in the y-axis, we have stress, and in the x-axis, we have strain. So first thing is this one, and then there is some deviation like this, and then we have right. These are let's say this is point this is a point so can you guys see, let's say this is origin, right? So from this point to a point, let's say this is o point. So from o to a, what is the behavior of stress and strain? Yes,
Constant.
straight line, right? Proportional.
Uniform.
Yeah, uniform. From A to O to A, this is proportional, uniform, yeah, uniform. And straight line and proportional, right? So from O to A, this is following Hooke's law, right? And then we have this B point. So this B point is not following the Hooke's law, right? Because from A to B, we see that there is no longer straight line. And then we have this C point, and then we have this D point, and then we have this E point. So all these things have different, right? So from O to B, if I deform this thing, then it can revert back to its initial state. So up to this point, the material is following the elastic property. Because up to this point, if I increase the stress and strain, so this will come back to its initial state. So this point is called the elastic limit. which is also called the yield limit. And this point is called the yield point. Okay, so this is called the yield point. So this point, did you guys understood this point? Yes.
Yes, sir.
So up to this point, if I deform the object, then it can go back to its initial state. But when I cross this point, right? When I cross this point, then it will not get back to its initial state, right? So then B to D and this point, right? So from B to D, it will not revert back to its initial state. So this point is called the plastic limit, right? This point is called the plastic point, right? So from B to D, if I deform the object, so it will not revert back to its initial point, right? So these are all plastic points. And specifically, this point is the maximum point I can deform this object, right? So if I increase this object any further, if I increase the stress any further, then this point will break. And this point is called the fracture point, right? So from, yeah, this is very important. So this is less than 1%, right? So from A to B and from O to B, I can revert back to its initial state. That is called the elastic limit. And from B to D, I cannot revert back to its initial state. So that is, this is the plastic limit, right? Plastic limit. So from B to D, I cannot revert back to its initial state. And this is the maximum stretch that I can give to the object, right? So if I put more stress, then it will break. So this is called the fracture point, right? So if I increase the stress after this point, so that object will break, right? So are these graphs clear to you? And this is called the plastic points. This point is called plastic point, right? This is elastic point or yield point, and this is called plastic point, right? So you guys please draw this curve. This is very important, and we'll write down all these important terminologies, right? So if we understand this graph, then all the things will be very easy, right? Please draw this graph.
Done, sir.
So from here it is. From here it is. And this is called the permanent. Right? Why am I saying permanent set? Because if I change this thing, so this will be permanently fixed, right? So it will not revert back to its initial state, right? And this is called the proportional limit, right? So here the proportionality constant is free. So this is proportional limit. And this sigma y is the so sigma y is the elastic strength or yield strength, and this sigma, this is represented as x or u. Here it is represented as u. So this is the ultimate tensile strength. Okay, so these are the important. You have any other things? Right, so you guys just look at the NCRT book, and then you can understand all these important right. So if this is also important that if this distance is larger, if this distance is larger, then the material would be ductile, and if this D and E point are close, right? So if D and E point are close, then if we break this thing any further, if you put some force further, if you put some stress further, then it will break, right? So if D and E point are close, then it will be called a ductile material, brittle material. And if this D and E point have a larger separation, right? So then this will be called ductile. So these are the crucial information from this class. So did you guys understood about all these information that we have? Yes? Understood everything?
Yes, sir.
Yeah, so did you guys understood all these
Yes, sir.
important?
Yes,
So
sir.
from O to A, this is proportional, right? It is following Hooke's law. And then from A to B, so it is getting back to its initial state. So that is called the elastic limit or yield limit. And from C, so from B to D, it is not getting back to its initial state, right? And from C, it is called the permanent state. So if I change the state at this point, then it will not regain its initial state. So this is called the permanent state. And D is the plastic limit, right? So if I increase any further the stress, then it will break. And this is called the fracture point after which the material breaks, right? So if D and E are close, then that is called brittle element, brittle material. If D and E are far apart, so then those are called the ductile material, right? So we will stop at here, and yeah, so I will see you guys in next class. And in the next class, we'll do some questions, and then we'll start this fluid chapter. So then we'll start the chapter. And tomorrow, so Elam, you stay here because I'll just do the recap of those rotational.
Sorry, sir. Can you say again?
Yeah, so you please stay here. So I will do the recap of. Oh, Amna, you have also this exam, right?
Yes, sir.
Yeah, so I will also do it. So you also stay here. And Rishita, if you want to revise those rotational and
Yes, sir.
yeah, if you want to, okay, so okay then.
So when will it be?
Yeah, so in half an hour, maybe just now, just now. Yeah, so did you guys note down all these portions? And you guys,
Yes.
yeah, look at in the NCRT book, and then please look at all these important. So now you guys know this graph, and you know all these A, B, C, A, D, and E points, right? So we have to just understand these points, and then you just see in the book, and then you understand all these important. Okay.
So you will take one more class in half an hour now?
Yeah, yeah. So in half an hour, I'll try to just revise rotation, gravitation, and this fluid motion, right? And then you revise all those things.
Sir, if it's today, I can't be there.
Oh yeah, yeah. So because you don't have any exam, Ishita. Do you have any exam?
No, sir, it was supposed to be on like 15th, but they cancelled it and they postponed it to January.
January. Oh, so you have ample amount of time, right? Good.
Yeah, so that's 20 marks, and then I have pre boards and then annual exams.
Yeah, keyboard doesn't have it, right? So keyboard has it. Okay, yeah. So okay, so you can leave and Amna
That
and
means are there boards for 11?
yes, there are boards for 11th class. Because board exam is only for this 12th class, right?
Yes, sir.
Okay, yes. Bye, Rishita, and see you tomorrow. In tomorrow class, I'll start with video.
Thank you, sir. Bye, sir.
Yes, bye, 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 Rishita, bye. Yeah. In rotation, what are the things that we have studied, right? So let us start from backwards. Then you will be able to understand all these things, right? So let us start backwards and yeah. So in this chapter, what have we studied? So in this chapter, mechanical properties of fluids. What have we done? We have done three things mainly. One is deformation, right? And then on the basis of deformation, we have understood stress and strain, right? And then we have talked about relation between stress and strain, right? So the major important thing that we have studied is Hooke's law, right? And it says that for elastic material, stress is directly proportional to strain. So this is the thing that we have studied, and it has a straight line graph. And then we have studied that there are modulus of elasticity, right? So one was this Young's modulus, and what was that? So this Y was longitudinal stress divided by this longitudinal strain. This we studied, right? The second thing we studied about shear modulus, and this was also called the modulus of rigidity. And this was represented as sigma. This was F by L delta X by delta L, right? And then the third thing that we studied was this bulk model. This was volumetric. This was represented as V. This was delta V by. So these were the things that we studied in this chapter, right? And lastly, what did we study? So lastly, we talked about elastomers, which had this kind of graph, and then we studied about the stress and strain. Right. So in stress versus strain curve, what did we understood? So first portion was this Hooke's law, and then we had this proportional limit, and after that we had this kind of behavior, and then we had this kind of right. So this was B, right? This was the elastic limit, and then we had this C, which had this permanent set, right? And then we had this D point, which was the plastic limit, and then E point, which was the fracture point. So these are the things that we studied in this chapter, right, everyone? This is fresh, right? This is just we have studied. And you guys do the example question of NCRT, then it will be more clear. So tomorrow I will do that, but you guys also try that. And then the next chapter was gravitation. So in gravitation, what did we talk? What did we talk about? First one was this Newton's force of gravitation, right? That we talked about, right, guys? Right. And what was the Newton's force of gravitation? So if we have two masses, right, m1 and m2, and there is a separation between them, which is r. So there would be a force which would be applied by, let's say, if this is the mass, so this mass will attract this thing in towards its direction, right? So the force of attraction was m1, m2, g, and r square. And this was a vector quantity, right? So then we talked about the superposition principle. So superposition principle, we talked about that the net force is the sum of all the forces, individual forces, right? And then we talked about the example of this. So we had four forces. Let's say M, 2M, 3M, 4M, and then we calculated the force at this point, right? Some m mass was kept in there. So we calculated the force, and it had four contributions. So one, two, three, four contributions were there, right? So this four mass will attract towards its side. This mass will attract towards its side. This mass will attract towards its side, and this mass will attract towards its side, right? So then we talked about the superposition principle, and after that we talked about the acceleration due to gravity, right? So first thing that we talked about was the surface. So at surface, what was the acceleration? This was simply g m by r square, right? This was the acceleration due to gravity, right, guys? So if we have this is the Earth, this is mass of Earth, and its radius was r, and the object is in here. So this will feel the gravitational acceleration at the surface, which was this thing, right? You go back to the notes and see the derivation. Right, you guys have all the, and then we calculated at a certain height. At a certain height, so what was the GH? This was R, and this was a certain height. This was H. And then we calculated, so this was mass of the Earth. And then we calculated the gravitational acceleration at this point, right, guys? So how much was that? This was G 1 minus 2h by r. This was the gravitational force, right? Gravitational acceleration at certain height, right, everyone? You guys remember, or you guys have forgotten? Yes, do you guys remember?